In this video, we'll continue to focus on the quadratic formula. We'll mainly focus on the discriminant and what it tells you about the x-intercepts of a quadratic function. Recall from the first video on the quadratic formula that if 0 equals ax squared plus bx plus c, where a isn't 0, then the quadratic formula tells us that the solutions to that equation are x equals negative b plus or minus square root of b squared minus 4ac all over 2a. The value underneath the radical, the number underneath the square root, is called the discriminant. So if we have a quadratic function f of x equals ax squared plus bx plus c, then the discriminant is the number b squared minus 4ac, the number underneath the radical. Let's do a few examples to see what the discriminant tells us about the x-intercepts of some quadratic functions. All right. Suppose we have the function f of x equals 3x squared minus 5x plus 8. This is a quadratic function, a second-degree polynomial. To find the discriminant, we need to find the value b squared minus 4ac. So that would be negative 5 squared minus 4 times 3 times 8, which is the number negative 71. So that tells us when we use the quadratic formula, we're going to have negative 71 underneath the square root. So if we want to find the x-intercepts of the function f of x, we let y equal 0, because that's where x-intercepts occur. So now we're solving the equation 0 equals 3x squared minus 5x plus 8. And now we can use the quadratic formula. The quadratic formula says if 0 equals ax squared plus bx plus c, then x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And so our x equals negative b, which is 5, plus or minus square root of, and we found the number underneath the radical, the b squared minus 4ac, was negative 71, all over 2 times 3, or just 6. But notice the number underneath the square root is negative, so this is not a real number. Square roots of negatives are complex numbers. So that tells us if we were finding the x-intercepts of f of x, the answer is a complex number. It's not a real number. We're not going to find the x-intercepts on the real number line. There are no x-intercepts to this function. When you look at the graph of this function, you will see it hovers above the x-axis, never touching it, because solving the equation 0 equals 3x squared minus 5x plus 8 results in no real solutions. For example, consider the function f of x equals negative 4x squared plus 12x minus 9. Let's find the discriminant of the function. b squared minus 4ac for this function is 12 squared minus 4 times negative 9, which is 0. If we want to find the x-intercepts of the function, x-intercepts occur where y equals 0, so we let y equals 0 in the equation. Now solving the equation 0 equals negative 4x squared plus 12x minus 9, we can use the quadratic formula. Plugging our coefficients into the quadratic formula, we have x equals negative 12 plus or minus square root of b squared minus 4ac we found is 0, all over 2a is negative 8. But notice square root of 0 is just 0. So instead of adding a number and subtracting a number to get two answers, we're adding 0 and subtracting 0, which results in the same answer. There's only one answer, negative 12 over negative 8, which is just 1.5. Only one answer. When the discriminant turned out to be 0, it resulted in an only one answer when we found the x-intercept. So there's only one x-intercept. This quadratic function is upside down. It's an open down parabola, and it just touches the x-axis and bounces off, hitting it at x equals 1.5, y equals 0. Let's look at another example. In the function f of x equals 3x squared minus 4x minus 5. Let's find the discriminant, b squared minus 4ac. For this function, b squared minus 4ac is negative 4 squared minus 4 times 3 times negative 5, which is 76. If we want to find the x-intercepts, we let y equal 0. So now we're solving the equation. 0 equals 3x squared minus 4x minus 5. And so we can use the quadratic formula. Plugging our coefficients into the quadratic formula, we have negative 4 plus or minus square root of b squared minus 4ac we found is 76 over 2a would be 6. And so it is 4 plus or minus square root of 76 all over 6. Square root of 76. That is not a perfect integer. 76 is not a perfect square. And so when you pull out your calculator and find the square root of 76, you can find a rounded decimal approximation of that number, or you'll have to just leave it as the square root of 76. There are two different answers here. We have 4 plus square root of 76 all over 6. And if you pull out your calculator, you'll find that that is about 2.1196. The other solution is 4 minus square root of 76 over 6. And if you pull out your calculator, you will find that that is about negative 0.7863. Two separate answers. And remember, these are the x-intercepts. We let y be 0, and this is what we found the x's to be. Two x-intercepts. One occurs at about negative 0.7863. 2.1196. F of x equals 12x squared plus 8x minus 15. We find the discriminant, p squared minus 4ac, is 8 squared minus 4 times 12 times negative 15. And if you pull out the calculator, you'll find that that equals 784. If we want to find the x-intercepts of this function, we let y be 0. So we're solving the equation 0 equals 12x squared plus 8x minus 15. And so we can use the quadratic formula. We find for this function x equals negative 8 plus or minus square root of b squared minus 4ac we found is 784 all over 2a, which is 24. Now this time, it turns out that 784 is a perfect square. The square root of 784 is 28. So this simplifies to negative 8 plus or minus 28 over 24. Okay, again, we have two answers. The number underneath the radical was positive, and so we're going to have two answers, negative 8 plus 28 over 24 and negative 8 minus 28 over 24. But this time we did get rid of that square root because 784 is a perfect square. And so x equals negative 8 plus 28 over 24, which is the number 5/6, or x could equal negative 8 minus 28 over 24, which is the number negative 3/2. Those four examples lead us to some conclusions we can draw about the discriminant in general. If we have a function f of x equals ax squared plus bx plus c where a isn't 0, so if we have a quadratic function, if b squared minus 4ac is greater than 0, so if the discriminant is bigger than 0, if the number underneath the square root is bigger than 0 when we use the quadratic formula, then f of x has two distinct x-intercepts, two possibilities. If the discriminant is positive and it is a perfect square, then f of x has two x-intercepts and they are both rational numbers. If the discriminant is positive but it's not a perfect square, then f of x has two x-intercepts, but they will both be irrational numbers. Discriminant equals 0, then f of x has exactly one x-intercept. And if the discriminant is negative, that's when we had those complex roots. We solved with the quadratic formula and found only complex answers, numbers that were not on the real number line. So if the discriminant is negative, then there are no x-intercepts.